Okay, just to recap what we discussed yesterday, I was talking about HANA platform architecture and different components and different software advancements of HANA. To reiterate again, these are the four components which made HANA to differentiate from the other database technologies. In-memory, column storage, and compression, high compression rate and insert only. There is a nice blog written by Werner. It's in the document, so you can refer this document for this information. So this is going to be the combination of all these four features together is going to get all the benefits for HANA. Okay. Yeah, this is the blog which Werner explained very well in a detailed way with some examples. Why the RAM is expensive? What is the cost of RAM? What is the pros and cons of having in memory everything in memory and having columnar storage? Pros and cons of when you combine all of them together. This is what you're going to get. Combining all the technologies together, finally you end up with HANA platform, putting all together. So that's how you get the benefits of an in-memory platform with all advanced processing speed, which other databases cannot do that. There are other databases which are better in one of these technologies, but not in all together. Okay, I go into yeah, we also discussed about the server architecture. I'm not getting into the details. So this is the index server. We will be focusing more on all the time. And we also have discussed about delta merge. We will come back to the delta merge concept when we advance in the SQL processing tables, data, partitions, and etc. After we understand the data tables concept completely, with indexing, partitioning, and etc., then we will come back to delta merge process. How do we make the delta merge control in a day-to-day business? Okay, then we started with SQL. Yesterday, I just created simple table schema and with some fields, and I've shown the difference between using double quotes when defining schema or table. Not using double quotes, both we have seen in yesterday's session. Okay, today we will be looking at the SQL continued with some more syntaxes. I started with DDL, data definition language, which are create, drop, delete, and etc. So these usually we don't do much in DDL statements in every day-to-day work because it is once it is set up, we don't really go and create or delete any tables in the system. It's going to be just one-time task during the initial setup, or if it is an application used outside of on top of database, you don't have any option to create the database table very frequently unless you need a customization to be done to, which mostly you will do it from your S4HANA or BW4HANA, but not from the database unless you are completely working on native HANA database. You don't do much on the DDL work, which is data definition language, create, drop, alter, and etc. But still, we never our focus is going to be on the native HANA data warehouse. I am going into the details of DDL as well, and then after completing the DDL, we will go to DML, data manipulation statements, which are very important uh, to work in data warehousing, ETL, data reporting, analytics. For all the other use cases, DML is very important. Most importantly, select statement is the most important thing, which you always 80% of your time you're going to run SQL with your select statement. How good you are in select statement, that's how you can say you are the better resource in SQL development, SQL developments. Okay, I have my enterprise HXE software running, logging into it. I created a demo schema yesterday to show some simple examples. I created a couple of tables, and I'm going to insert some data into this into these tables, or I can create a new table also. So yeah, as I said yesterday, I got all the syntax here. In order to speed up my content preparation and content uh, flow in a better way, I will refer to this notepad and take the code in whenever it is required, and then paste it into my SQL window. As I said again, it is not really mandatory to have everything remember on your top of head. You can always refer to the SQL help documentation for reference. Yeah. Okay. Yeah. Let's start today's session. Okay. I'm going to create a simple table again. I've shown you the syntax, but again, so this is a creating column table. Table name is EMP details, and I've got two columns here. I'm specifying it is a primary key, employee number, and not null. And employee number and department are the string data types. So every column I'm defining with a data type, and if it is a primary key, I will specify it as a primary key. So it notes the integrity constraints and etc. And then you got other non-primary key columns followed after. And then each statement in SQL, HANA SQL ends with semicolon. And this is the end of the statement. I'm ending it here. Just say execute. Incorrect syntax. I have to, each column must be separated with comma so that you're differentiating the table fields properly. So now it is created. So I've got a new table created. I'm going to insert some couple of records into it and just have the syntax here. You copy paste it. So I'm just insert into my table and values. So I'm following the same order. How did I define my table? See, so actually this is a different table. I'll have to create my employee number, and then the next one is name, and then department I can say like HR. So string data values are enclosed in quotes. And integers are direct numbers. You don't have to keep it in quotes. Okay, I prepare two data records and then say okay. One is executed and another one is not. Yeah, max length violated on position. Yeah, just I've got to, I made the department as 4 only. Since I have given 5, it did not accept. So second insert did not go. So I'm inserting again the record. So now it is fine. So I inserted 2 records. I can go and check my data in the graphical user interface, or I can do select statement right here, or both are fine. So this is my table. I'm saying open data preview, so I can see the 2 records here. That's a simple insert I made to enter the data into the table. Okay. The display data, I can do it from select star from the table name also. So I'm always referencing my schema. It is always a good practice to associate your schema name before your table so that you don't get different or confused every time when you're using stored procedures, or there may be names of the tables which are same in both schemas. So it is always a good practice to associate your schema along with the table. Okay, so I made the simple table. I created with primary key and some other columns with some data types. I used int and varchar as data types, and slowly we will know more data types when we proceed with some other examples going forward. I also inserted the data. You can make a note here that when I'm inserting, I'm follow the same order what I define my table. So the first field value goes into the first field, and the second value goes into the second field, and third respectively. So I have to make sure that my order is exactly same as how I define my table. If I have to pass the values to the tables, like in ABAP, you corresponding fields, you got an option to do that, right? So similarly, you can do that also. We will know that how do we do that in the next in the next sessions. Okay, so if you wanted to comment any line, you just add comments. Means comment, you don't want this processor to understand this set of lines, then you comment with /. So this is what so I get to command, that's it. So it went into blue. That means it is not identified by the compiler when you execute the program. Okay, and if there are multiple lines, you can enclose them between // and asterisk, and end with / and / and sorry, asterisk and // whatever in between these two are going to be commented. As processor compiler is going to ignore those ones. Okay, and then next one is we'll get into some more examples. Okay, yeah, let's see an example of copying one table from another table. So I got a table. I wanted to create a similar table with the same structure of the table one. So I can do it this way: create column table. My name, new table is going to be table 2. Like, what is my reference table? Is going to be demo.emp details. So with that, I'm going to get a new table with the structure of emp details into the table 2. So I'm going to run this one. Oops. Where's my SQL window? I'm sorry, I'm not in SQL. I have to go into the SQL. I'm opening a new session. Okay, I run this one. It is executed. Now I can see there is a new table created here in my schema. This is all basic. You may get bored if you already knew it, but I'm going to be a bit faster in these initial basics because it's very simple and you can easily get through with it. Okay. Yeah, I have a new table called table 2 here with the same structure as emp details. So if I wanted to copy with the data, I'm going to do the same thing, like demo.emp details. I will add the keyword with data. So this command is going to get me all the data in employee details into the new table 3. Let's see what is in table 3. I don't want to go into the GUI and UI and get the table. I can always use select statement to see what is in the new table, right? That is much easier than refreshing. So I got select star from demo.table 3. I got the data in this one. This is the data of what we inserted in table emp details table just before in my previous session. Yeah. One other thing is every time if you don't want to give the schema name, you can just say set schema demo, which makes this session is set for this schema. So next time onwards, I can ignore, I can directly refer the table name. So it identifies that my table is referred from, sorry, I have to run this first, set schema. I did not run it. So now this session is set for the demo schema. Now I can run this one. So now you can see as long as you are into this session, your schema is defaulted to demo. Okay, and then you can work on without referring to the table names. But as I said it before, I will always try to keep my schema name associated with the table names. Okay, that's from the simple table creations and etc. I got another example to show you to define the multiple primary keys. In my previous example, I've shown you to define one primary key. Let's say I've created a column table with the same structure, so I don't want to type in again. I will just copy paste the syntax, same create column table. I'm changing my schema. I'm using my schema this time, my personal schema. So going forward, I'll be using this schema to keep all my objects in place. I wanted to create a table name called material plant, and I'm defining with material plant location. And this time I have two different columns as primary key. You can call it as composite key in whatever the database language terminology, but it is a combination of two different columns acting as a primary key in this scenario. So I'm explicitly defining the primary key in the end by saying material and plant. If I wanted my location also to be in the primary key, I can do that. So by adding location, as I said, this table I wanted to store at this level of granularity of material and plant together. I'm doing this way. It's done. So my table will have a primary key with two different columns. So similarly, you can define number of primary keys together in the end. The reason let's say it is useful when let's say you got 10 different fields and you wanted to define this as one primary key, and you want to skip the second column and wanted to give the location as a primary key, you cannot do that. So because all the primary keys are to be in sequence. So let's say if you wanted to skip several columns in between when you're defining the primary key right there just next to the field, it is difficult. Sorry, it's not difficult. It is not possible. The syntax doesn't allow you to do so. So in order to achieve that, you can do the primary key keyword in the end and define all the primary keys from the above list of the fields. Okay, going on to the next syntax. I'm building another master data table like thing, simple customer master. Same structure, create column table, customer, and then I'm giving 4 columns, and then I'm defining 2 different columns as primary key. Only new thing I have seen in this example is I added a date column, valid from and valid to. These are all date types. You got um, local date format, HANA native format. So we have seen integer, varchar, and then all your strings are going to be defined in varchar. Your numbers are going to be integer, and your amounts and currency fields are going to be with decimal. And you got tiny int, big int. It is all just the number value which it can hold. If you wanted to know the number value, as I said, you can just refer to the reference document. You don't need to remember the top of it, but yeah, it's easy. You can just refer to the SQL reference. This one. Also, you have another document which is HA 150. This is very precise and simple. Which is used for the SAP trainings for SQL basics for HANA. You got very simple and examples to show you and also you got a lot of exercises in there, which I liked it most. When you are especially working on DML, you got a lot of exercise in it. Very basic document, what is a table? So it starts from there. So if you got really interested and time, you can do, if you don't know the basics, etc. But it's pretty very simple. Okay. For the technical reference, yeah, I have the SQL reference documentation. This is HANA 2 SP02. That's the latest what we have got. Um, because every service pack you got new statements are updated, right? I'm searching for what? Int. Okay. Big int. So these are the different numeric types: tiny int, small int, integer, big int, small decimal, decimal, real double. So you wanted to know the exact format of those data types, you can search further. Yeah, I got these. Yeah, you see these numbers. These are the numbers. So in tiny int is 256, big int 1 2. Yeah, these are the numbers which you can make a note of it to while working on. Approximately, you can just say very small numbers will go in tiny, and minimum numbers you can get to the integer, and the big one go to big int, etc. Very easy. If you are going beyond that number, it is going to throw an error. So that how you can recognize that it's not accepted with your data definition. Similarly, date, time, timestamp. You for everything you got the structure, how it has to be. You put it in natively to understand in HANA. Okay, you can see the date format is YYYMMDD. That's the default format. So when you are inserting some date, you can choose this one. We got all the examples to do these ones. So yeah, if any case when I have any new syntax here and you don't understand, that's where you will go into the SQL's help documentation and get the more information for that. But I have captured every different syntax in my notepads, these notepads. Okay, let me create this table. Oh, I already put it in. Okay. Error. So you can see what yeah, line 7 column 27. So when you define my, I have to end with ending brackets. That's what it is missing. So I'm going to say this one and then say it is good to have errors so that we'll understand what's going wrong in this. It's kind of I don't want everything correctly taken from some sheet and put it in there. If we miss something, it's going to give an error. So far I'm repeating the similar syntaxes, so I'm not really typing in to create the syntax. I'm copying paste. Whenever I get a new syntax, I'm going to type in, and so we will understand what are the general possible syntax errors we get when doing for the first time. So this table is created now. Yeah, and yeah, this is just to explain the date format and how we define a column with a date format. And then we going into a different syntax, which is primary key and foreign key relationship, pretty much known. Um, um, all many times. You can easily understand the definition of the primary key and foreign key relation from your previous experience and etc. So you're going to have the table here. I'm creating a simple table, column table. Okay, I'm creating a department table with just one department and the name, 2 columns. And then I'm going to create another table which is employment details. Uh, just the one more column additionally here. Oh, sorry. Let me take the syntax completely. So what the department, what is the new syntax I've got here is the foreign key. I've defined a foreign key, which is department column referencing my department table on delete cascade. So what is it doing? See, this is my primary table, my primary key table. That's my initial table department. So first I'm going to have all departments set up in my company. Then I will start inserting some data into my employee details so that each employee, whoever getting inserted into employee detail, will have a reference to the department. Let's say if I don't have reference check in my department table, if I introduce something new in department for an employee which doesn't have a department key in the my primary key table, which is a reference check failed. So in order to make it integrity constrained with reference to reference master data and transaction data, probably if you would have come through from background of ABAP or BW, you would have seen that when you are inserting some transaction data, you perform some checks to make sure that particular column, what value what user is entering has a primary key, it exists in the primary key or not. So that's a reference check we perform. So that can be achieved using foreign key reference. So I'm defining this department column, which is a primary key in this table, as a foreign key in this table. So there is a link made between department name and this department name. Okay, so if I'm going to insert any record directly into the department, it doesn't allow. The system doesn't allow, just because of the reason that it has to exist first as a primary key in this particular table. You can check that. I don't have the syntax. Yeah, it is one syntax I got. Let's try that out. So I'm trying to insert a record in the second table, foreign key table, which is a brand new record, and as an employee join, and his name is John, and then I'm inserting 50 as a department number. So it's saying an error, saying that line couldn't find table. Oh, sorry. Did I execute this one? No, I think I have to execute tables creation first. I think it got executed. Let me run this one also. Now my second table also created. Now I'm running the insert into. Yeah, foreign key constraint violation. Failed on table with error. Just as I said, so I'm going to insert record first in the um, insert into EMP table, sorry, department table, values. What is the primary key I wanted? 50 is my primary key, and then department name is HR. Okay, so if I insert this record in the primary key table, then if I start inserting this record, it will allow. Yeah, I see this is now allowed. You can check the data in this table. Yeah, so done, right? So that is one other thing. So foreign key relationship is very important when you're working in an ETL project to identify the logical relation between your dimension table and master data table or dimension table, both called same, and then transaction data table. And you say another one is delete cascade. Delete restrict, there is two things called delete restrict and delete cascade. So what are the differences between delete Cascade? What is the difference between? So with Cascade, if primary key table data is primary data table data cannot be deleted directly with the effect the deletion will occur on the transaction data table also. What does it mean? So if I try to delete the data from the primary key table, and it also deletes the data in my a corresponding data entry in my transaction data table also. You understand, right? So if I say delete restrict, it doesn't allow you to delete. Say that you got a your primary key has been used in some table. You cannot delete that. So since I do delete Cascade, I can delete my master data from this table. Any question? Delete Cascade. You can there is no such restriction. Somebody can go into this table and delete the data from the primary key table, and then what happens? What is with that result? Your target table is going to lose the connection between your primary key table and target table, which leads into inconsistencies. So unless you make sure you wanted no reference between primary key and foreign key tables, you can say so, delete Cascade. But you may be saying most of the times delete restrict, which makes no one can go to this primary key and table and delete any primary key entries, right? So it's very important when you say restrict or Cascade while defining the table. Any questions? Just let me know. Just type in there. I will answer them. Um, can I think someone has a problem in listening to my voice? Is that breaking or is it clear? Can anyone just let me know in the chat when everyone just if if you can do that? Okay. If anyone else has got problem, then please let me know. I think one person has some problem, but if any other person has any, yeah, I think he dropped. I think he has got a bad internet connection. Okay, yeah, let's go to the different syntax. I hope you're following me or I'm not. This is all easy things you can easily practice and understand. So instead of I tell 10 times, so go very slowly. It is not going to help. It is more when you type in these syntax on your system, you get better understanding of them. Okay, if you wanted to check all the referential constraints built in the system, you can do so. Say this is the statement. There is a system table. You got system schema. All the referential constraints you can find in this space. Why I'm losing my SQL every time? Okay, let me do another one. So this is the system table. You can see all the references created with respect to reference constraints. I wanted to keep my schema name in where class so that I can see. So since it is a string, I have to enclose this in here. What happened? This is the case sensitive. Whenever I'm using string, I have to make sure my schema, what is in the system, has to. So it's very important. So some people always try to do everything in caps. This is the reason. So it did not identify my schema name when I typed in lowercase. It's not a keyword. It's a string, a specific value I'm giving. In order to do that, I have to give exact name in quotes. So there was a constraint created. You can see on the table name EMP detail, the column name. So and all the details you can say. Update rule is restrict delete rule cascade. Yeah. So for deleting, I made cascade explicitly. For update, I didn't specify anything. So by default, it takes restrict for updating it. Even for delete also, if I don't specify it here, whether it is restrict or cascade, it is going to take restrict by default. Okay, good. And then next topic is loading data into tables using flat files. It's a very simple. I will quickly run through this example. So create a table with the structure. So since it's again same exercise, I'm not typing in, I'm copy pasting. So I create a table customer and define a primary key as a customer ID. Syntax near customer ID. What is that syntax? Okay, let me take the varchar. Cannot use duplicate name. Okay, I used the customer table before, so that's what it's complaining. So I can say customers. Yeah, it's created. So I'm going to insert some data into this using flat file. It's kind of an extraction. We're going to see the detailed extractions using data provisioning technologies like SLT and data services. But for this time, I'm using HANA flat file import. So I got import. I'm importing the data from local file. Okay, so I'm in HANA content, SAP HANA content, data from local file, and say next. I'm going to give my schema system and then select file. I have to get my file, so I have file stored already in sample data, which is customer master data. I'm bringing up this here, and header row exists, header row 1 first, and then importing all data. New schema, no, I'm not creating a new schema. I create an existing schema. So let's say I'm going to bring my table into this place. So the table is in my schema. Go to the customers, and set. Okay, next. Okay, so this is the structure of my flat file. I got customer ID, and I got name, city, country, and then phone. So I can do a direct mapping by dropping one column to the other column, or I can also do map by name, so automatically it can map it, but I'm just, for the first time, I'm mapping one by one. So that's it. I made my mappings, and then this is going to be my data output, and then say finish. Data should be processed. I'm going to check my table, select star from customers, right? Got my data. So this could be, I will use this data for my testing and several example purpose. So I don't want to insert all this huge data using insert into a statement. So that's why I used flat file extraction. Yeah, it's simple. So I thought of bringing in the initial sessions itself. So I'm going to work on this data because I will have certain different scenarios which I can show you with the good number of records. Okay. Just stop me when you are not clear on any of the topic, but you with this video, when you have it with you, you can practice anytime, but any topic is missing with an understanding, question, clarifications, just let me. Okay, moving on to the next syntax. I imported it and then defining the global temporary tables. Yeah, we've been looking at creating tables, right? So far, whatever the tables we have created are all for permanent and persistent tables. You're going to retain the data all the time. In this example, in this case, I'm going to show you a temporary table creation. So temporary table is usually required when you are processing some data in a program like stored procedure and etc. It holds the data during that particular session and then it clears out. So it has a different more I mean bigger perspective and purpose, but at this moment I'm only showing you how to create that table. Okay, let's see. Let's create global temporary column table. Yeah, I'm not defining primary key. It's not a permanent table, so to define a primary key, so that's why you cannot define a primary key. That's why I put it in comment. The syntax is simple. Only addition is create global temporary column table. That's the only difference between create column table and the create temporary table. Rest of is same, and you one other note you may have to put it in is primary key cannot be defined there. I'm going to run this one. It got executed. Can I insert the data into global temporary table? Yes, of course. That's the requirement, right? In your stored procedure, you got a temporary table. You may insert some data into temporary table and process the data according to your requirement. And at the end of your session or the commit, your temporary table is cleared out, right? So that's the purpose of having temporary table. So that means I must be able to insert some data into it. So let's say I'm inserting two records, same structure, same syntax, no change, just two fields. I'm inserting a couple of records, and that's it. I can just do the select from the global temp table. Okay, I can see these two data. So this is a temporary table. As long as my session is on, I can have this data. Let me open and see another session. Sorry. You don't see that. Only you can see it in this session. I think you got the difference now. But it is defined. I mean, it's available with the structure in the other session also. But just that data is not available there in the other session. You got another table type, local. Same structure, just you got instead of you replace the keyword local temporary table. So I'm going to have another table created here. Okay. Sorry, I gave the name but did not give the fields in there. That's I have to define the field names, right? So I'm giving these two. Okay. My local temporary table is created. I can insert some data into it. What I'm doing are very basic, so you will be able to go through it very quickly. Replacing it, replacing it. I inserted 2 records. I wanted to display it. Yeah, and then let's see. I got my 2 records. Okay, same select. I'm going to do in a different session in this place, and you will identify the difference between global and local. What is it saying is it's it is not defined. So it even doesn't recognize there is a table with this name in another session. So but with global, it is able to identify the table name, but which means there is a structure availability, but no data. Data is local. So to conclude this, in global temporary table, data is local and structure is global. In local, data is local and also the structure also local. Yeah. Yep. And then going on to the different syntax. This is all about tables. So far I'm talking about tables, temporary tables, persistent column table, row table, and etc. Yeah, logging. Yeah, this is another concept of memory allocation. See, you can read from this notes that with no logging keyword, data is global and it is not permanent. It will be deleted when the physical memory is reached to 90%. So what does it mean? If I say my table creation with no logging, it's going to be created as a temporary table, and when the memory reached to the full extent, or 90% according to this interval which we, according to the threshold we set it up in the administration, it is going to clean up the data what is in this table. See, I'm not defining as a complete persistent table here, temporary table. I'm specifying as a full-fledged column table log. But even though I create this as a column table, if I say no logging retention 300, so that means it, with this keyword of no logging, it will still act as a global temporary table. But not since from the table creation time, but when the memory reached to the full 90% space, and also retention, it wait for 300 seconds, and then it is going to clear everything. I cannot show you this in an example just because I cannot bump up my memory to full 90%. So I cannot really show you this one, but you will, just to make sure you understand this one. That's about logging. Yeah, merging. Yeah, this is what I was talking about yesterday's session. I will come back to this merging in a later section. It needs more understanding of, I have all the comments, put it in there. We will be coming to the merging in the next session. Okay, yeah, next syntax is partitioning. So you know the concept of partitioning very well, right? So partitioning is setting up several blocks for your tables so that data goes to that particular partition, and retrieval can be much faster because it knows, the processor, the server knows where to go and pick the data from. So usually in your BW or any other external applications, you do based on certain time column for partitioning. Similarly, you can do that in the database, HANA database as well. So there are several types of partitioning. Hash, range, and then round robin. I don't get into the details of round robin, but I cannot show you in this system, but I will go into the hash partition and range partition. So hash partition is simple. Let's say you got uh, 4 index servers, and according to the settings defined in the index server, your table is going to be a partition into 4. So each partition will be saved in one index server. So that's how hash partitioning is done. If it is a really big table, it is better to do the partitioning on hash, based on hash theory. Okay, so you're going to use the partition column as your primary key column. So there is that's the most preferred column to be used, because of the type of partition it is hash partition. Okay, let me see the create a table in partitions 3. Same column table, I'm adding partition by hash on the primary key, and partition number of partitions I said 3. Yeah, it's created. Let me go to the table from GUI just to make you some that the hash. Yeah, so you can see that the table, column table, but 3 different kind of blocks. That's when you have a partition defined on the table, you can identify that in here. I'm double clicking on the table and go into the table definition. You can see this is and then further properties, it's not temporary table, so it's none, and runtime information. So you can see the partition here, parts 1, 2, 3, ID 1, 2, 3. So it's not range. That's why it's by column. Okay, that's the partition specification is hash 3. That's what we give, 3 different partitions. You can see that. Let me insert some data into it. I can insert any session. It's a normal table. Okay, I have to end every statement with the colon. Yeah, come on. What is missing? Hash values. Let me go into the table definition. Okay, I've used the department as in int. Sorry, 10. I have to keep it. This kind of this makes a lot of delay, so I thought I wanted to avoid this. You can easily figure it out, these ones. Okay, now done. I'm going to refresh it. Open definition. Sorry. Yeah, you can see the size occupied in for the first partition is 59 and second partition is 59. So it got 2 records which occupied occupied into these 2 partitions. Sorry, 3 records. First record went into the first partition, and then the next 2 records went into the second partition, and then third is going to be empty. So all your records will be partitioned according to your partition ID in this case, in this hash partition. The next is hash partition, and then sorry, range partition, and then I'm going to stop this session with this today. It's a time-based partition. I just correct it here. It doesn't make sense. I will correct it later. Okay. I don't know. There will be several syntax issues. I typed in. It executed. Yeah. Okay. So the syntax is create column table, all the fields, and then my primary key defined, and then partition by range on the join date. This is a date column. And then what is the partition value? 2015-01 values between these two are going to be in one partition, and then all the rest will go into the others partition. So just made two different partition, and then insert some data which fall in this timing. So this is most commonly seen partition all the time with a number of records grown in your system. So I'm going to refresh. I need to show you in the graphical. Okay, that's the range partition. I open it, just double click on it. And for runtime information, and then I got two partition. So you can see records. First two records went into the first partition, and then last record went into the third record went into the second partition, just because. Let me see what. So the first two records in 2015 year. So according to this criteria, they went into this, and then the others, the third went into the others. So similarly, you can define several partitions based on timing, and then you will be able to classify your data according to reporting query when it is grown up more. We will also see the delta merge. This is what delta storage and main storage I was talking about yesterday. So initially it is going to be delta storage. When you run the delta merge, the total memory from delta storage will go into the main storage. We will see that. So I inserted three records. So this is big. That's why you see the delta storage is big. After delta merge is run, it can it moves it moves into main memory. We'll see that, and we'll see the delta merge concept in detail. And last one is this is the range partition. The same. I've given two different partitions. You can try it out. Yeah. And round robin, it's the classic example for BW. So usually, see, BW cube is, it's by default it is created with four partitions. I don't know whether you observed it or not. When compressed, it there are 1, 2, 3, 4. Those are the standard partitions, and 1 and 4 partitions are used for data processing. So when the data initially loaded into BWQ, it goes to the fourth partition, and then when it is compressed, there is still compression valid in BW. So people say that compression is not required in BW, but that's false. That's a false assumption. It is required. When you do the compression in BW, the data goes from fourth partition into the first partition. Okay, and there are other two partitions, 2 and 3. 2 and 3. They are used for inventory. There is a separate compression process for inventory with respect to movements and history data revaluations. If you cannot recollect the whole BW days, yes, fine. It's there. There is a marker compression process in BW inventory, which is done special in a special case. So for those scenarios, it is going to use the 2 and 3 partitions. So this is controlled by round robin from SAP system. So round robin is something which is controlled by system, defined by system, to properly handle the partitions. So that means you don't generally use round robin for your use cases. So either you go with the time-based partition, mostly 80% of your time, and some index-based partition, which is hash. Right? Yeah, these are the use cases. If the query is on time data, range partition. 3 years before data, if you don't want to use, obviously you partition your data based on date. If your query is on mass data without having certain date, certain set of data which is not related to date, you go with hash partition. That's about the basics of SQL, and I'm stopping here. I'm at the top of hour, and in the next session I'm going to see some more advanced syntaxes with respect to DML, which is like select, uh, select, update, insert, and etc., which are really important. And then I move on to scripting. So it's going to be not boring. If just a refresher for the people who already knew it, just to get some syntax. And I hope I'm going to complete these SQL in next 4 to 5, maybe another 5 sessions. Then I can go into the data provisioning or modeling, one of these two topics. Any questions? Just type in there. I can answer them. Okay. If you don't have any questions, I can. Yeah, I'm going to share the video, yesterday video and today's video. Um, it just needs some formatting to be done. Yeah, I will just give this notepad for the day one basics SQL. Yeah, uh, definitely you require it. I don't think if you haven't got your syntax preparation before and not worked on HANA database or native HANA modeling, you would definitely require this precise syntax. I put all the required things together in this one page document. So if you are good with this document, this particular script, you almost cover in the DDL. Uh, truncate and dropping, we will see. Sorry, truncate goes to DML. Drop we will see tomorrow. Alter and drop we will see tomorrow, and then we continue with DML statements. Yeah. Okay. Yeah, I'm going to end this session. If you have any questions, if you couldn't ask now, you can send me an email. I will respond to you. You got my email. All right. Thank you. Let's meet tomorrow.